Thanks for coming here today. My name is Sébastien Miglio, and I would like to welcome you to this Unreal Summit. It's a great pleasure to be here with you in Seoul today. I'm Director of Product Management for Unreal Engine at Epic Games. I'm based in Montreal, and very happy to be here with you today. We're going to talk about virtual production. I'm going to give you some example of how virtual production is being used by our customers for what type of different use cases. And we're going to take a look at as well at some of the features that Unreal is bringing and adding to the product to make virtual production more easy to use. So, in this session, we're going to talk about virtual production. First, what it is and how it is changing the way storytellers can visualize complex scenes, complex projects, and that could not be basically done in real life with traditional production method. And today, virtual production is much more than just a buzzword. First of all, it has been around the industry for more than a decade. It was first introduced by projects like Avatar from James Cameron. And what is happening these days with virtual production is that it is going through a major transformation thanks to real-time technology like we have today with Unreal Engine from Epic. And not only virtual production revolutionized. So, no, sorry, I don't have much cable. So yeah, not only it revolutionized filmmaking through real-time technology, but it really changed the way basically cinematographer, director can achieve with their narrative storytelling. So traditionally, what you would need to shoot a movie, shoot a short, or any type of animated content is basically a camera, actors, and a location. But with virtual production, the camera, actors, and location can be completely virtual. And the result, thanks to many technological achievements, is that it can still follow largely the rules of live-action filmmaking, especially with real-time engine. Things remain, you will see, very similar. The way you're doing virtual production, in fact, is made so that it's as close as possible to what happened with a previous traditional technique, except that you can do much more. So with virtual production, we basically refers to all the way that we can combine data acquisition, like from motion capture system, real-time rendering, and traditional filmmaking techniques. Basically, everything that you learn on how you do a movie can be reapplied in this new production workflow. And in a nutshell, basically this is where the physical world and the digital worlds can meet together for cinematographer. With virtual production, directors can work on a physical stage, as we can see here, but they can view and interact with the virtual environment and the character using the existing devices that they would have to do a traditional movie. So of course, as you can imagine, this can vary a lot depending on the type of production you are doing and about the style and the requirement of the project. So virtual production is a technology, but it's up to you to define the workflow and the way you want to apply it to your project. It's a tool that can help you to do more, but that does not enforce certain type of methodology. So this is what a typical virtual production workflow can look like. So virtual production tools tend to relate mostly around the capturing of action, so that someone that is looking at a screen, like a director with a virtual camera, can almost see a finished composite image of what the final shot may look like. That was not really possible before because it requires offline rendering techniques and they had to wait to see the result. So the whole idea here is to simply replicate what you might do with live action camera, but that you cannot do with such a camera because you might be crafting in a virtual world or virtual character that cannot be filmed for real. If you want, for example, to do very complex shots like helicopter or long camera crane motion, that would be very complex to do on a closed stage. If you want to shoot giant robots with a motion capture actor, this is not something you would be able to do in real life. But it's not only about being able to visualize these virtual worlds. It's also about being able to change them as quickly as you want directly on stage. So this is why real-time rendering and game engines have become a big part of virtual production. And why real-time rendering and live-action filmmaking and visual effects have started to converge together into the same environment. And rather than relying on the fix-in-post mantra, the goal of virtual production is to develop high-quality assets early in the process with a virtual asset department. So the virtual asset department here is responsible for producing real-time assets that are high quality. You can consider them as the next generation of pre-visualization because those assets will then be able to evolve and continue the life cycle when they are provided to the VFX vendor to produce the final shot. And these assets are going to be used on stage with the director of photography, and the content will be as close as possible to the final pixel to support the director's creative decision. So as we will see, there's a different type of production technique that you can use on stage. Another benefit of virtual production is here around the edits. Because with real-time rendering, we can basically generate dailies and send this to edit suite directly on stage so that the director and the editor can see basically how the entire timeline on a movie is looking like. They can generate instant dailies for the studio reviews, and they can also see changes and retake the content and reiterate around the virtual art department and the stage together. So this creates a very close iteration loop that is happening live on stage with the director. By doing this, the director knows better what he's producing, and he doesn't have to wait for months, for example, with post-production, to start realizing what the movie will look like. So there are different types of content that you can produce in virtual production. And the first one is basically pure animated CG content, where you have only virtual world film with motion capture actors or with pre-frame animation that was done prior. So motion capture actor can be visualized in real time, as we can see here in this reflection demo. And basically by using HMD devices, like here Gdc Vive, the actor can be aware of the environment around them. They can look around, they can see the set, and they can make eyes contact with the other actor, which is really important because the action is then much more plausible. And the onstage operation are often taking place at different steps. First, the director, using VR scouting tools and a virtual camera, can basically start to place his shots in the right location and can start to do the blocking. Then the actor can start do the performance under the direction of the director. And it is really important, as we see here, that one actor could basically play multiple characters because virtual production allows the ability to do retakes. Finally, once the take is done with the actor and the blocking has been made, the director can revisit the entire result and modify the framing, retake some scene, and change the camera motion. So that gives a lot of flexibility to do variation. Thank you. So another example of virtual production is for broadcasting and TV. So if you've seen a weather channel presenter or a newsreader interact with broadcast graphics during a television show, you've seen that a lot of use cases that you can have for virtual production. Such broadcasts are very common these days, and they came to the attention of media audiences recently with a weather channel and the work they have done to simulate a storm surge impact from the Hurricane Florence, as we can see here. Basically, broadcasters make the use of virtual production often because they can control the environment that is being filmed, typically a green screen studio with fixed lighting and camera that can be tracked. There are several systems that works with Unreal to allow real-time graphics to be composited with the presenter and interact with them. In this video from the Weather Channel, the system that we are using is from the Future Group based in Norway, and it's called Pixotop. It is a system that combines track camera, green screen treeing, and real-time compositing inside Unreal. Thank you. But there are other systems available as well. For example, the system called Reality from Zero Density and other from ROS. So there is an ecosystem that is very strong in the broadcasting space. MBC in Korea is using virtual space for documentaries and TV series like the Dinosaurs one that was available in Korea. Then we have in-camera VFX. So here, it's the idea of doing rear projection like the old cinematic technique was done in the early days of film production. So today, thanks to real-time technology and the fact that LED panels are much cheaper, in-camera VFX allow you basically to combine, like we are seeing here with our friend from Stargate Studio, LED panel with actors and props all shot together live and producing final pixel. So it is not anymore about playing back pre-rendered media from servers, because Unreal Engine is capable of driving live multiple displays, including off-screen secondary renders for lighting and reflection. So not only you can shot with your camera as a stage, but you are also lighting and creating a very photorealistic environment directly inside the camera viewfinder. So it brings back basically all the context on set to be part of the film creation process instead of something happening months later in post-production. And the imaging that you are shooting in a sequence, like in this case, in a train or in a car, well, usually what you would have is the actors looking at green screen, and the crew and the staff on stage don't really know what is happening either. So everyone is disconnected for the reality. And basically the only way for you to see what will happen is that you're going to have to wait sometimes months that the post-production does the work. Well, with in-camera VFX, we can bring the experience and everybody live on set together. And when you have hundreds of shots that are taking place in front of a green screen, well, there is a financial cost as well of doing then all the post-production, the keying, the compositing. Here, most of the effects will be done on set. So of course, at Epic, we have a tradition of experimenting technology that we are using for our own project so that it ensures that it scales and addresses the production needs. As we said, we eat our own dog food. And while we have been creating cinematic for a very long time at Epic for the game we have been producing, like Gear of Wars, Fortnite, or Robot Recalled, we have done also other projects that we've used to push the boundaries and experiment the combination of real-time and digital worlds. first example that I would like to share with you is Senua. And the Senua project was done in partnership with Ninja Theory and Cubic Motion back in 2016. And this demo is now a few years old, but I would like to mention it because it touched on so many key elements of virtual production that we have since delved much deeper into. That project included virtual camera, digital humans, multi-tech layer rendering, and high-fidelity performance capture, already in 2016. So when we introduced it in 2016, that new process of shooting computer graphics content using the same technique found for live action was very revolutionary, as we were able to get on-set final edit within few minutes. At the time, doing that type of process was taking months. And these included high-fidelity performance capture combined with real-time digital human. In this case, all the motion capture was done with the Vicon system, and we were using a proprietary system for cubic motion for the facial capture. So with the virtual camera for looking into the virtual world, the layer recording, where one actor was able to lay down multiple performances, basically acting against her opposites themselves. So one actor was doing all the characters of the shot, which is very practical as well. For this, we introduced a new tool called Sequencer. And Sequencer brought to Unreal a timeline-based system, similar that you can find in non-linear editing software like Avid or Premiere. And we were easily able to hold the timing, add cameras, change level parameters over time, for example, doing light variation inside the scene. With Sequencer, all the data from the motion capture, the facial capture, was recorded with the voice of the actress, and it was possible once the text was recorded to start blocking the next shot. So it also accelerates the production process. The next year, in 2017, Epic worked on the Human Race project with the Blackbird from the Mill and with our friend from Chevrolet. And the purpose of that project was to bring real-time tracking and compositing of all those elements together. So before we look into a little bit deeper into the project, I'm just going to play you the video so that you understand what it is.
Louis, you've won so many times in your career. Monaco in 09, for example. How do you do it, man?
Well, you know what? There's always a way to win. There's always a way through.
Louis is going to be the first human ever to race a car operated by artificial intelligence. Let's meet the competition. Aja.
Hello, gentlemen. In my simulations, I have beaten Lewis 148,623 times.
And how many real races have you won, Aja?
This will be the first.
I see all the possibilities, Lewis. You cannot pass me. You do not win.
There's always a way through.
Lewis, congratulations. This was a historic win.
Well done, Lewis. But our race has just begun.
So everything you've seen in that commercial was done in real time. And to create this commercial, we had to introduce a bunch of new features to Unreal Engine. First, for real-time compositing, we added Composure. And Composure offers a blueprint-based frameworks for dealing with scene capture and being able to assemble the way you want. At the time Composure was released, it was a fairly complex tool to use. But since the 4.22 release of Unreal Engine, we have added user interface to manage easily the passes, the mates, and how you can assemble all the components. And basically, we have made compositing in Unreal Engine much easier to use. The second improvement with the human race was that we added to sequencers the ability to play back open EXR sequences. So there's a couple of plates, like all the video that you can see overlay or underlay, that were coming for open EXR passes. And on top of that, for the on-stage user, for the director to be able to visualize everything, we've also added video I/O support from SDI card. So in this case, for example, there are 360 degrees panoramic that were captured by the Blackbird and that were basically used as reflection map onto the car. And basically during the, the shooting, we were able to composite those reflection map and transmit them to Unreal directly over the without wireless system. And basically this enables us to produce an AR image of the virtual object tracked and composite seamlessly into the scene and in real time. So basically the director was able to frame and see the virtual car on location reacting live to lighting and environment changes. And this was really important when you are shooting an object that does not exist yet in real life. For example, when Chevrolet introduced new cars and start to do the creation of the commercial, the car has not been manufactured yet. It does not exist outside of computer software. So having access to this technique really enables them to start producing the content even without it exists. And of course, the extra benefit of having a live commercial is that it enables the viewer, for example, the customer, to configure the object present in the film as this commercial was rendered live and nothing was pre-rendered. Finally, last year, in 2018, the Reflection short was revealed. That was a project we did with Lucasfilm, and that also included their immersive department, ILM X-Lab. And ILM has always been the perfect partner for Epic, as they worked with us on Rogue One and other Star Wars related projects to blend real-time technology into the movie industry. That Reflection demo was done in two parts. The first one was a GDC trailer that we will see shortly that was mostly focused around ray tracing technology. And then there was a SIGGRAPH real-time live demo where basically we were able on stage to replace some shot by other live, showing all the virtual production tools that we have today. So first, let's look at the Gdc Cinematic that we produced last year.
What's the story with all the elevators lately? I heard Kylo Ren destroyed the one over in D sector. If you ask me, who's ever in charge of this place should be transferred to Hoth. What? What? You think she heard us? Yeah, I think she heard us. At least we blend in for once.
So, this project was a great example of Epic using basically all the virtual production technique we've been producing to generate very great looking cinematic and something that is really appealing to the audience. And with the Reflection demo, we worked on dynamic light sets, ray trace shadows, reflection, multi-user, and VR editor. We're going to talk about that shortly after. Also, it was important to notice that the actor and the director were working together in virtual reality live on stage, and everything was recorded right on the spot. The second part of the reflection demo was a real-time live stage demo that we did at SIGGRAPH in 2018. And this is where we demonstrated all the virtual production technique all together. So basically, we replaced a shot live on stage, and in this case, we wanted to have one of the stormtroopers to act more with a bigger reaction when seeing Captain Phasma. And so to do that, we had to capture a new performance, a new camera, change a little bit the lighting, and insert into all of that and edit it on stage. So if you look at some of the technology we use to do that, first of all, for virtual production, there were several PCs connected together using the multi-user editor mode. So basically, multi-user allow multiple people, crew member, basically to work together in the same Unreal environment. So when you do a changes in one editor, it is replicated to the other. Then we had Mohen, who's on the left, and he was basically directing the sequence, he was modifying the environment, and he was also using a Vive controller, being able to basically block the camera shots and control the virtual camera. Then we had Gavin, who was basically acting on stage and performing the stormtrooper. There was also additional machines that were used in this example. So first of all the live performance were using LiveLink, and all of that was recorded onto another PC. And finally, there was one dedicated machine for real-time ray tracing rendering that basically gather all the information from the other data stream and perform the final rendering of the scene. And we're going to talk about some of those features later, but that was a perfect example of how efficient and flexible virtual production tools can be, as it could be demo on stage in front of an audience, and we're able to perform all the changes live. So now that we've looked at the type of project that we've been able to do at Epic Games over the last 3 years in order to improve virtual production capabilities of Unreal Engine, what I would like to do now is talk a little bit more about the key features. What are the components inside the technology that are made available to people so that you can produce virtual production-based projects as well. So we can start with LiveLink. And as we've seen, there's a lot of devices and hardware on the stage for using virtual production. And all those data that are available on stage, they have to be sent into Unreal and made available to all the system. And so that's why LiveLink is Unreal's unified entry point for all the motion data. So track camera, motion capture, facial capture, retargeting system, for example, motion builder, and any type of bespoke devices. We have customers who have their own device, their own camera, boom and rig, and using encoder, they are transmitting the data to LiveLink inside Unreal. And one of the things that LiveLink does well is that basically it ensures that all the data that are stamped, so in this case, okay, I'm gonna show it here, sorry. Yeah, so in this case, we usually are using a master timecode generator, and basically that timecode generator sends LTC or VITC signals to all the devices. So each of the devices receive their own timecode data, but each of those devices had its own processing time and latencies. They all do different things at different time. So when the data is computed for facial, track camera, and motion capture, and you need to reassemble all the data together, it is important that you can synchronize everything together. And that's why with LiveLink, basically all the data that are pushed are automatically resynchronized inside the engine, but also they are recorded at their source frame rates. So it means that if you have facial capture running at 120 frames per second, motion capture at 200 frames per second, but the tracking camera system is only working at 24 frames per second, all the raw data are recording into sequencer. And that allows you, when you change the project, to always preserve the maximum quality. Today, LiveLink is supported by most industry standard performance capture systems. So for facial capture, Dynamic Seize and Faceware are using it. For motion capture, we have Vicon, Xsense, as well as other. And for camera tracking system, we have Mosys and Stipe, but other as well, like NCAM. So we have a lot of variety of partners that helps ensuring that the production run as seamless as possible. Then, as we've seen, collaboration is essential on stage between the director, the actor, and all the crew operators. So that's why we introduced multi-user editor in Unreal 4.22 after a year of development. So what multi-user editor does, it's offer a collaborative environment for all the stage crew where all the changes happening in one workstation are automatically replicated onto the other. And the multi-user editor is built on a client-server model. So we have a server running here that is connected to all the clients. And basically, a single server can host as many concurrent sessions you want. Basically, each session represents a different virtual workspace where basically all the instances of editor connected can collaborate on one project. And today, all the virtual products, the different components that we are adding to Unreal are developed so that they are compatible with the multi-user editor. So for example, this is something we are doing for a project called Fury for Fortnite. And here you can have VR scouting at the same time of motion capture and editor usage at the same time as virtual camera, all together in the same space. This is an example of how multi-user works at Epic, where basically in this video we have Colin that is playing with some of the scene lights, while the motion capture data is broadcasted through LiveLink to all the editor instances. So the changes that are happening on stage or some of the workstation are basically replicated everywhere. And that's really the way people work in the traditional film industry, where when you do a change somewhere on stage, like moving a light, everybody can see that on the stage, where that's why we are trying to develop here with multi-user. Important to note that multi-user is still in early access mode and the development is not yet completed. So we are still improving it. Right now it is mostly made for virtual production, but the goal of Epic is to make available multi-user for game development and any other type of use case. A very good complement, as we've seen, of the multi-user, the perfect companion, is our VR editor, because it allows a director to basically perform location scouting. So using an HMD and a VR headset, a director can easily go and start to perform changes. He can find the right spots, find the right blocking, and start to change different things. So this is a very good, important tool. VR editor has been in Unreal for quite some time now, because it was introduced 3 years ago, but there is a dedicated VR editor mode for virtual production that is really made for directors that are not computer expert or Unreal experts. So now, let's talk about Sequencer. Sequencer is our multi-track editor. It's used for creating and previewing cinematic sequences in real time. And for those who are used to Unreal and knows Unreal well, basically Sequencer is replacing Matney. They share the same concept. I mean, both can be accessed at the same time in the editor today, but soon Matney will be deprecated and pushed aside. The benefit of Sequencer is that multiple people can perform changes in the timeline at the same time. The second benefit of Sequencer is that it's shot-based. So it's really easy to understand for people from the film industry or people who are producing cinematic. And besides Matney and Sequencer, we have two other tools that we have in engine, and which are the sequence recorder and the take recorder. I will talk about the take recorder a little bit after, because it's quite important for what we are seeing today. One of the benefits of Sequencer is that basically you can quickly visualize and move things in 3D. And sequencer allow you to act like a director, a cinematographer, or an editor would do. So sequencer leverage a concept of master sequences. A master sequence is a container, basically where all the shots and sequences of a cinematic are contained. So here, if we look on top, here we have our main master sequence track, and it's made basically of different shots. And in this case, it contains shot 10, 20, and 30. This is how we name things at Epic. We are leaving the unit digits free in case we want to insert something in the middle. So if you dive into the shot, so if you open one of these shots, you end up to the UX you have below. And basically, it allows you now to start to see the shot camera location and all the parameters associated with the shot, like the character track, the audio track, the effect tracks. And everything is represented with keyframe and timeline like you could find in most of the DCC tools like Maya, Motion Builder, or 3ds Max. So for people that are used with those products, it's a very similar concept. Sequencer brings also a very powerful concept that we call the shot overrides. That means that if you have a scene that takes place that you are reusing a couple of different times, you could, for one specific shot, change some parameters without impacting the other shots. That's why we call it override. And it's very practical. When you move the camera and you have an object in front of the camera just for that shot, you could just move the objects and clear the camera field. But when the camera comes to the next shot, the object is back where it was. So doing some small changes like that just for specific shots and overrided property is something that people do very often in virtual production. So at this time, we've talked about sequencer. Now we can talk about tech recorder. And for those who know Unreal well, you will notice that the tech recorder is basically an improved version of the sequence recorder. The sequence recorder that was introduced with sequencer in 2016 is being replaced. And the main reason is that with the tech recorder, we want to design a better UX that are really made for virtual production. Because when you are with director, actor, photography director on stage, it can really be fast and furious. You have to do changes very quickly and under a lot of pressure. This is why you need a very simple and easy to use UX so that you can navigate and perform changes easily. And really, that improved UX is one of the most important differences between sequence recorder and tech recorder. So, the real power of tech recorder is that you can basically record and play sequences back so that you can review footage immediately on the stage. So you capture and right away you can play back. You don't have to go anywhere else. And then it gives you a timeline and the footage right away available if you want to do some editing and some cutting. So it's like a mini sequencer for quick edits on stage. The other benefit of tech recorder is that it's fully integrated into LiveLink so that it is capable of recording multiple tracks at different frame rates. And that's very important when you want to mix external hardware with internal tech from Unreal. Then, as we've seen earlier, the benefit of virtual in-camera VFX is that the actor can be placed into live scene instead of being composited in post-production. And photographic elements can take advantage of the environment lighting and reflection. So to control all this system on stage, we have added a new system called N-Display. And N-Display, it allows you to distribute the rendering across a cluster of PC. So in this case, what you would have is a multi-user system with a server and the regular editor. And then you would have one PC for each LED panel or each projector. And the benefit of N-Display is that it handles all the gen locking of all the channel to ensure a perfectly synced synchronization. And basically, when you have multiple LED or projectors side by side, they will show the same frame at the same time all the time, which is really critical. Also, if you are shooting with a camera, it allows you to genlock the camera capture system with the display system all together, so you have no tearing effect. Another benefit of N-Display is that it's responsible for the deterministic seeds. So if you have particle effect, you want to ensure that when the particles are going from one PC on one LED to another PC and another LED, they are consistent. And basically, this is something that is handled also directly by N-Display. In this example, we wanted to even further ease the usability of the system on stage. So that's why we made it compatible with the multi-user editor. And now what we've added is the ability to remote control. So in this case, we are using a tool that is called Touch OSC, and it allows you to create modular touch remote control on an iPad. And using the OSC protocol, we can control all the system for one iPad. So that allows you, for example, to manage the color correction. If you want to change the tint, the hue, the brightness of all the LED panel, you can do it from one system. If you want to start all the PC, stop the system, or change the level, that can be also handled by that. So it's very easy on stage when you have a lot of PC to control everything from one location. Of course, since we are compositing live actor with virtual environment, we also had to add the video I/O as we've seen previously for the Human Race project. So here we've added different features. The first one is the support for SDI card. So Unreal supports AJA and Blackmagic card, but there are other coming from Bluefish, and other vendors are now starting to add the Unreal support. And not only you can ingest any SDI format, we support up to 4K resolution. We support also genlock and timecode support. But with the media capture panel, which is the one here, we also added the ability to output the results of the compositing from the editor directly to an SDI stream. And that can be done from SD to UHD resolution. It supports up to 10 bits precision, for example, for HDR. It supports progressive and interlace formats, and also includes support for all the FPS, like drop frame, 29.97 frames per second. And finally, because on stage you have a lot of hardware and you don't have much time to troubleshoot, we also have the timecode provider here that is used to inspect and troubleshoot all the input into your system right away. And now that we have video inputs, we've talked about compositing. So we mentioned that we had Composure that was added to the product. Basically, Composure is just a framework where you can create scene capture from any render passes inside Unreal Engine, and then you can take those scene capture and reassemble them the way you want, basically with a layer-based system. So when you are building compositing graph, it is much easier then to control the foreground, the background, and insert video in the middle or video clip. And also, Composure includes the rotoscoping paint for matte generation or green screen if you want to combine green screen scene in real time with computer graphics. So that could be used, for example, for pre-visualization on stage. Now, we've looked at all the core, some of the core features we have in Unreal. There are many other tools that are in Unreal that could be used for virtual production. Just for example, real-time ray tracing. We've not talked about that today. There are other sessions from Marcus about this. But we are using also additional tools outside of Unreal to simplify virtual production. And the first one is Perforce, because with Perforce, we can synchronize the project and the data across the project. But there's an issue with Perforce. Perforce is complex to use, especially for the artists. So that's why we have developed another tool that we use and call Unreal Game Sync, UGS. And UGS is available with the engine. And the main benefit of UGS is that it's a wrapper around Perforce, and it allows you to easy access for artists to push their work and grab the updated work. Because, as I said, perforce can be a little bit intimidating, for the artist and the less expert user. So finally, I would like to talk about the future a little bit and show you an example, because we have done a lot of work for a special project to bring virtual production, but what we want to do now is bring that to the outside world and is our user. So that's a very interesting example. That's a UMG tool that has been developed for iPad. And basically, it allows, when you are on stage with a lot of different machines, to basically, you have to shout, you have to tell to that people, do this, do that, etc. That's a lot of things that you need to do and work on. Well, with that tool, the director can control the character that is displayed, the lighting, the camera, the triggers, and alone with his iPad, the director can make all the changes across all the editor station without having to ask anyone. The director is becoming completely autonomous to change everything he wants on his own without having to ask anyone. And we believe that this is one of the future of virtual production, because it makes the tool much simpler and it hides all the complexity of Unreal technology to make it easy for virtual production. So, as you can see, Unreal Engine is fairly used in the TV and film industry for virtual production projects, thanks to our performance, flexibility, and the support of open standard and source code availability, of course. Now, even if virtual production is fairly new, Unreal Engine offers already a lot of features to help cinematographers and unleash their creativity. Thanks for your time. It was a very great pleasure to be here with you today. Let me know if you have any questions.